Hello everyone, and welcome to the first video on anti-differentiation. And as the name suggests, differentiation, it's a long word to spell. It's the opposite of differentiation. And whereas with differentiation we had a bunch of different rules to help us in differentiating, anti-differentiating, there's no rules, there's no structure to it. Basically all we're trying to do is recognize patterns and sort of go in the opposite direction. Like, just to give you an example, because the derivative of x squared is 2x, then we look at 2x and go, well, we can figure out where that came from. That's what we're sort of looking at doing. We're going the other way, looking where it came from. And so basically we can start with a bunch of stuff that we do know. So I'll just list a couple of functions, and what I'll do is also list the antiderivative, and we're going to write this as the integral of f of x dx, and we'll just sort of draw a bunch of these up. So if you have x to the power n, what happens is the power increases by 1, and you divide by that power, and you get plus c out the other end. Also, if you, well, I'll just draw this line between there like that. If you have 1 over x, then what you're going to get if you anti-differentiate is log e modulus x plus c. Like that. We know that from past endeavours. If you've got 1 over some linear function like that, you'll get log e of ax plus b. But because of the chain rule when you're differentiating, that'll be 1 over a. Okay, and similarly, thinking about what the chain rule would do to this, e to the ax plus b will just go to e to the ax plus b, but you'll have to divide by a to get rid of what happens when you differentiate with the chain. Whoops, you'll figure out that. Good, then you've got sine of ax plus b. We'll go to, instead of cos, because we're going the other way, it's going to be negative cos and of ax plus b, but again we have to divide by a in there because of the chain rule, and also cos of ax plus b. We'll go to sine ax plus b, again 1 over a. And if I've forgotten any c's, and I have, got to be always careful when you anti-differentiate to add the plus c. And one more, when you've got something that's linear raised to a power, so something linear raised to the power, we'll go to, again, you'll have ax plus b. Okay, the power increases by 1, you divide by that power that you increased by, but you also need to divide by a as well, and so we get that there. So there's your sort of list of rules. I would have this always handy when doing anti-differentiation, because you'll always need to be aware of those until you get used to them. So I'll just do a handful of examples to give you an idea of what we're talking about here, but then we'll sort of move forward. So if you're asked to figure out the integral of cos 2x minus 1 dx, if you look at your formula sheet, this is in the form cos of ax plus b, and so the answer, well, cos goes to sine, and so you'll have sine, you leave inside as it is, and you divide by a there, so it'll be half that plus c. It's easy, you just need to follow the rules. Okay, what else we got? 1 over 5x plus pi, something like that, dx. Look at the formulas again. What that'll be log e of 5x plus pi, just reading it straight off the formula, and then we're going to divide by 5, so 1/5 of that plus c. And I'll just do one more quick one. What's probably a good one here? Integral 3x plus 2 over x plus 1, something like that. In that situation, we're always looking to put it in the form of something that we know. So if we look at this, At the moment we don't know how to anti-differentiate this, but can we change it so that it does? Well, we can actually perform a division, and so we could take out x plus 1 as a factor on the top line. That gives you 3x plus 3, but we want 3x plus 2, so we'll just subtract 1 off there, like that, x plus 1, and if we divide through, we get the integral of 3, because if we divide that by that, minus 1 over x plus 1 dx, and what that is equal to, if we now integrate it, whoops, we're going to integrate, integral of 3 is 3x, and this 1 over x plus 1 is minus log e x plus 1, and we're going to divide by the coefficient of x, which is 1, so actually it doesn't affect it, plus c, and so that is your answer there. So get playing with those, have a good go at those. I'm going to quickly run through a definite integral now. Definite integral. And what definite integrals are there, well, I'll show you what's not, so I'll just show you the difference. Definite integral looks like this. You've got some integral of anything, doesn't matter, something like that. And the difference is a definite integral is evaluated between two values of x, so like between 3 and 5. So that's definite because we have some terminal, we call these terminals here. It's evaluated between 3 and 5. This is an indefinite integral. It's just the integral, it's the general solution to that. Okay. So what you get in there, you'll get a number answer, a numerical answer to a definite integral. With an indefinite integral, you'll get some function or expression. So that's the difference between those two. And when you're evaluating some definite integral between a and b of some f of x dx, what that is equal to is when you integrate that, so capital F of x of f of b minus capital F of a. In other words, you perform the integration as per normal, but then you substitute in the point b into the expression and subtract substitute the point a into there, and you get fb minus fa. Okay, I'll just do one quick example of that. I'm not going to labour it much, but let's just do one here where I do an integral of let's do 2 to 5, something like that. I'm just going to make something up, of x squared plus 1 over x plus 2 over x squared. I might have run out of space. Probably jam this in. I'll have to go across the page and make sure I can. Okay, so let's just integrate this. I'll just rewrite this if that's my example. I'll rewrite that as 5 to x squared plus 1 over x plus 2x to the negative 2. And what that does, if we write them as powers rather than fractions, just makes it a little bit easier to integrate. So what we do in this situation, when we perform the anti-differentiation, we just put these little square brackets and then we write the anti-differential into here. So x squared becomes 1/3 x cubed. 1 over x, what's the integral of 1 over x? Well, that's plus log e of x, like that. And this one here, well, the power of negative 2 goes up by 1, so it'll be plus 2, it'll be x to the negative 1, and then we're going to divide by negative 1, so it'll end up being minus 2x to the negative 1. So that's our integral, and we're going to evaluate that between 5 and 2. We write it like that. Now you notice here I haven't put the plus c in. When we're doing a definite integral, we don't need to put the plus c, because what happens when we do this subtraction is that plus c just cancels out. It disappears. It doesn't affect the answer at all. And so don't need to write that in. What we do now is substitute the value of 5 into here for x, and then we subtract that and substitute the value of 2 in for x here. Okay, so I'm going to run out of space, so you'll have to forgive me. I'm just going to try and squish it in. And I shouldn't have chosen these two values, but anyway. So what we've got is 1/3 x cubed, 5 cubed is 125. So I'll just write it 125 over 3 plus log e of 5 minus 2 over 5. Okay, so we've substituted 5 into this, That's what we get there. And I wish I had chosen better values, but I haven't. Subtract, and I'm going to try and squish it in. If you put 2 into here, 2 cubed is 8, that'll be 8 over 3. I've chosen terrible values. Plus log e of x, which is 2, log e2. And then if we substitute 2 into there, that's 2 over x, so that'll be 2 over 2. So that would just be minus 1, like that. Okay. Right, so this equals, and we'll just evaluate there. We have 125 over 3 minus 8 over 3 is 117 over 3. Let's write that now, 117 over 3. And then we've got minus 2 fifths, and we've got minus 1. That's minus 7 fifths. Oh, actually, sorry, there's a minus there. And so that makes that a plus, so I'm going to scribble that out. So I've got minus 2 fifths plus 1, so that's plus 3 fifths, pardon me. And then we've got plus log e. Now when you've got, I'll write it out so that no one gets confused. Log e5 minus log e2. Now I'm just going to leave this for now. You can add those two together if you've got a calculator. I haven't got a calculator in front of me. I couldn't be bothered doing that, that's yucky. But what we can do with these logs is put those together. Log laws will say that if you've got a subtraction with the same base here, then that will be log e5 over 2. And so that's your answer, but you'd simplify that, of course. And that's how to do definite integrals. You perform the antidifferentiation, you put it into little square brackets, put your 2 terminals there, and then you substitute each of those 2 terminals. Put the 5 in there and put the 2 in there and subtract them together, and you get the answer there. And there, that's a numerical answer. It's a number of some sort. Okay, and yeah, that's antidifferentiation. Enjoy.